Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn frame of reference. It is one of the interesting topics in physics. How do you say the object is at rest or in motion with constant velocity with respect to some frame of reference? Now tell me, what is frame of reference? We have already studied the definition in our second lesson itself. If we imagine a coordinate system and the position of the particle, this is my position of the particle. The position of the particle is described relative to it. Such a coordinate system is called frame of reference. Or we can say a frame in which an observer is situated and makes his observation is known as his frame of reference. It is associated with the coordinate system. Coordinate system means here it is nothing but a Cartesian coordinate system, or simply we can say coordinate system with the time is nothing but frame of reference. Either frame of reference or reference frame, both are same. For an example, imagine you threw and caught a ball while you were on a train moving at constant velocity. To you, the ball appears to move vertically upward and downward under the influence of gravity. Here the observer is inside the train, but to an observer stood on the station platform, the ball would appear to move in parabola with constant horizontal component of velocity equal to the velocity of train. The different observations occur because the observers are in two different frame of reference. Next we will discuss the types of reference frame. There are two types of reference frame. One is inertial frame of reference or inertial reference frame. Another one is non-inertial reference frame. Let us see one by one. Here, if it is inertial frame of reference means Newton's first law is valid. Another important condition is in this inertial frame of reference, the force F is equal to 0 and the acceleration A is equal to 0, then the velocity V is constant. You know, dV by dt is nothing but our A. Here V is constant means obviously A is 0. Inertial frame is nothing but rest or constant velocity, or we can say uniform motion. If it is inertial frame of reference means Newton's first law is valid in this frame of reference. And another important condition is F is equal to 0, A is equal to 0, V is equal to constant. These are all the condition for inertial frame of reference. What is Newton's first law? Every object continues to be in the state of rest or of uniform motion unless there is an external force acting on it. This is Newton's first law, and you know that Newton's first law tells about inertia. What is inertia? The inability of an object to move on its own or change its state of motion. This is called inertia. Now we are studying about inertial frame of reference. That is why I said Newton's first law valid in this frame of reference. So first point I explained. Next we will see how F is equal to 0. An object is unaccelerated, that is whether it is at rest or in uniform motion. We can infer from Newton's first law that the external force on an object must be 0. But for our practical purposes, we can treat our earth as an inertial frame of reference. And you know that all the objects in the earth experience earth gravitational force. If then on earth an object is at rest or in motion, there are no force acting on it, because various external force cancel each other. I will explain this point through this example. Here, consider the book is at rest on the horizontal surface of the table. It is subjected to two forces. One is force due to gravity, which is nothing but weight, which acts in the downward direction. Upward force acts on the book by the table. That force is called normal force. Say this normal force is N and the force due to gravity is W. The book is observed to be at rest. So, the net external force on it must be 0, which means this normal force equal and opposite to gravitational force, or we can say force due to gravity. This normal force equal and opposite to weight, so these two forces cancel each other. The object never picks up acceleration in the horizontal direction, since no force acts in the horizontal direction. Next important point is, all inertial frames are moving with constant velocity relative to each other. What is the meaning? Here, the train is moving with a constant velocity v. So, train is one inertial frame because it is moving with constant velocity. Here, one person is standing on the platform. He is at rest. So, this is another inertial frame. For this observer, the train appears to move with a constant velocity v. Same way, for this observer is inside the train. For this observer, this person appears to move constant velocity. That is why I said all inertial frames are moving with constant velocity relative to each other. Or we can say, if an object appears to be at rest in one frame, may appear to move with constant velocity with respect to another inertial frame. Instead of train example, one car example is given. Here also the car is moving with constant velocity with respect to ground. So this is one inertial frame. Here one person is standing on the road. He is at rest. This is another inertial frame. How do you conclude the situation? If an object appears to be at rest in one frame, may appear to move with constant velocity with respect to another inertial frame. That's all about inertial frame of reference. So far we discussed about what is frame of reference. There are two types of frame of reference. One is inertial frame of reference, another one is non-inertial frame of reference. If it is inertial frame of reference means F is equal to 0, A is equal to 0 and V is equal to constant. These are all the condition for inertial frame of reference. How do you say F is equal to 0? It is not because there are no force acting on it, because various external forces cancel out each other. You know, for example, the book is on the table means the vertical component of forces cancel out each other. Next one is non-inertial frame. What are the condition? If it is non-inertial frame means A is not equal to 0. If it is inertial frame means A is equal to 0 without acceleration. Here A is not equal to 0 and we have change in velocity. If it is inertial frame means V is constant, but here we have change in velocity. For example, inside the car I hung one ball. The ball is at rest because the car is at rest. If I suddenly start the car, the ball appears to accelerate backwards because initially the ball is at rest, continues to be in the state of rest. If I suddenly start the car, the ball appears to accelerate backwards even without any force acting on it. Here the car is not an inertial frame when it is accelerated. So this kind of inertial frame is called non-inertial frame of reference. The rotating frame is also a non-inertial frame of reference because you know that rotation requires acceleration. Either rotating frame or A is not equal to 0 means we can say that frame is called non-inertial frame of reference. Earlier I said for all our practical purpose we can treat Earth as our inertial frame of reference. But you know that Earth rotates about its axis and also orbits around the sun. But in our day-to-day life we simply ignore the rotational effects of Earth. That is why I said Earth is our inertial frame of reference. There are some exceptions. Suppose if you want to analyze the motion of the satellite or wind pattern around the Earth, we cannot treat Earth as an inertial frame of reference. So far we discussed about what is frame of reference, how many types are there. There are two types. One is inertial frame of reference, another one is non-inertial frame of reference. If it is inertial frame means Newton's first law is valid, then F is equal to 0, A is equal to 0, V is equal to constant means we can simply say inertial frame of reference. If it is non-inertial frame of reference means A is not equal to 0 and we have change in velocity. Rotating frame is also called as non-inertial frame of reference because rotation requires acceleration. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.